We know how to solve equations like this. 2x minus 9 is equal to 0, right? We know that we need to get x by itself, right? And this isn't really necessary to write down, so there's not really a great spot in your notes for it, but don't worry about that. I'm just kind of introducing something here. So we know 2x minus 9 equals 0 is an equation we can solve. It's a linear equation, and it's a linear equation because the x is raised to the first power. Okay, but what if we change it? What if instead of multiplying by 2, I raise x to the second power? Well, now we need completely different techniques for solving an equation like this because um, everything we've learned has been based on x being raised to the first power. But even if I add 9 to the other side, I still don't have x by itself because the x is being squared. Right? So we're going to need a new way of approaching problems that aren't linear. So what we're going to use is something called the zero factor theorem. And what it says is that if you have two numbers, two mystery numbers, I don't know what A is and I don't know what B is, but I do know that if I multiply the two together, I get 0. Well, the only way that can happen is if either A is 0 or B is 0, right? There's no other possibility because if both A and B are not 0, then when you multiply them, it's not going to give you 0 as the product. Okay, so that's what the zero factor theorem tells you. So the way we can apply it to something like the example below is if I have x minus 7 times x plus 2 equals 0, then it must be true that either x is equal to 7 or x is equal to negative 2. One of those one of those two numbers would have to get plugged in for x in order to make the left side equal 0. Now, that left side, if we were to FOIL it out, then it would look like this, right? AX squared plus BX plus C equals 0. So this is what we would call a quadratic equation. And it's going to be a quadratic equation when you have square term and then potentially also an x to the 1 and a constant. And so this is how we're going to approach quadratic equations. We know that we can take something that looks like this, and sometimes we're able to factor it into something that looks like that. And if we can, then we can use that zero factor theorem. Here's another example where we've already got things in factored form. So I can set the factor of x equal to 0, and I can set the other factor equal to 0. And there's a little bit of work to do on this one. So we get x equals 0 and x equals 3/4 as our answers. So those first two examples, everything's already factored, okay? But if it's not, if it's just a quadratic equation and we have this set equal to 0, then we can ask ourselves, can x squared minus 3x minus 18 be factored like we worked on in some previous videos so that I can apply the zero factor theorem? And the answer here, of course, is yes. So remember, we're putting an x here and an x here, and we're thinking about how can negative 18 break down and also have those factors add up to a negative middle term. So here's our possibilities. And of course, this is the one where 3 plus negative 6 is negative 3, giving us that middle term. So plus 3 minus 6. As soon as I've done that, I can solve these two individual equations, and that's coming from the zero factor theorem that says I'm multiplying two things, and the only way to make the left side equal 0 is if either x plus 3 is equal to 0 or if x minus 6 is equal to 0. So there's our two solutions there. And of course, to do this, right, it's the zero factor theorem. So we can only draw these kinds of conclusions when we're able to set one side equal to 0 and have it as two factors, or maybe more than two, but factors multiplied together equaling 0. So if you have a quadratic equation, but you don't have one side equal to 0, your first step needs to be to make one side equal 0. And then you can set about trying to factor. This might be a good one to remind ourselves of the AC method since the numbers are kind of big, right? So 25 times 4 is 100. And because this is a negative middle term, it's going to be -1 times -100 as a possibility. -2 times -50. And remember, these numbers will need to add to make -29, so neither of those work. Looks like, oops, looks like this one's the one, right? -4 times -25. We'll go ahead and just finish this off real quick. -5 and -20 would have been a possibility, and -10 and -10, but this is the right choice. So I can break this down into 25x squared minus 25x minus 4x is the same as -29x plus 4 equals 0. 25x can factor out of the first two terms, and -4 can factor out of the second two terms. So my factorization is this. And of course, we're setting x minus 1 equal to 0, which is easy to solve. And 25x minus 4 equal to 0. Okay. Why don't you try the next example there, see what you come up with. Right, so after pausing and doing this problem, hopefully you started by getting the right side equals 0. And then you can do the AC method. I think is a decent idea just because the numbers are so large. And again, we're trying to make a negative there. I'm not going to make the full list this time, and here's why. Clearly, -1 and -144 are not the right choice, right? Because this number is not that large. When I see 144, the first thing that comes to my mind is -12 times itself. And that's exactly what's going to add to give me -24. So I'm just going to jump straight there. So I can factor out a 3x, factor out a -4. So when this factors, it's 3x minus 4 times itself, right? And when that happens, of course, 3x minus 4 squared is what you get. And so this time you're only setting just the factor 3x minus 4 equals 0. And that can happen sometimes, right? You just end up with one answer here. So x is equal to 4/3 is the solution to that equation there. So as a general rule, here's how we can approach these quadratic equations by factoring. So you're going to write the equation in standard form so that one side is equal to 0 if it isn't already. Factor the quadratic expression completely. And then set each factor containing a variable equal to 0 and solve the resulting equations. And then, of course, step 5 is, always check your work. Just make sure that if you check your work and you see a discrepancy, or it doesn't seem to check out, make sure the mistake's not just in the checking before you go, erasing answers and that sort of thing. So, a couple other examples here. This first one asks us to solve this. And at first glance, it might kind of look like it's all set up and ready to go because the left side's factored. However, notice that the right side is not equal to 0. So it's only if we could scroll back a few, right? Like in this example, we were able to just immediately set x to 0 and 4x minus 3 equal to 0 because the product was equal to 0. So we could apply the zero factor theorem. Here, I have quite a bit of work to do actually, because it does me no good to have it factored if the other side isn't 0. So here you got to start by distributing through, and you get x squared minus 4x equals 5. And then get one side equals 0. Let's see. To create negative 5, you're going to need plus 1 minus 5, right? And the outside and the inside will add to make that middle term. So x plus 1 equals 0. So x equals negative 1. And x minus 5 equals 0. So x is equal to 5. All right, and then the example here, this is an opportunity to remind ourselves of when we're factoring, we need to make sure that we don't forget about easy factoring. So before you dive into trying to do kind of the reverse FOIL process or the AC method or anything, check to see, is there anything common to each term? And you can pull a 5 out of each term. Not only that, but we usually like to have our x squared term be positive whenever possible. So we'll find it helpful to pull out a negative 5, in fact. So you'll have x squared minus 4x, because negative 5 times negative 4 is positive 20, and minus 12, since negative 5 times 12 is positive 60. And then we'll factor what's in here. X minus 6 and x plus 2 are going to do the trick, right? As you can see, the inside plus the outside gives me the middle term. So the one other thing that's important to point out here is that, of course, we're going to set x plus 2 equal to 0 and get x equals negative 2. And we'll set x minus 6 equal to 0, x equals 6. But we're not going to do anything with this negative 5. It's just kind of along for the ride. In fact, if you wanted to up here, you could have divided both sides by negative 5 to get rid of it, right? Because dividing 0 by negative 5 would still have given you 0. But you can just ignore it because there's no variable there. So you're only setting factors that have variables in them equal to 0. So there's our two solutions.